All right, now that you know this is bad code, and now that you know how the stack works in general by using arrays, we'll just re-implement the stack data structure in some better coding practices. Now let me create a folder called stacks and a file called stackarray.c, and just that creates a stacks inside this and stackarray.c. Now what I'll do, I just don't want to waste my time writing it from scratch. I'll have it and I'll just update this code. Okay. Now it's not just one header, but we'll be needing 4 headers this time. Okay. The first thing is standard library, because we'll be using dynamic memory allocation and we'll need access to malloc and calloc. And we'll be using the standard bool.h because we'll be not using ones and zeros this time. We'll be using trues and false. Okay. And also we'll be using something called limits.h, and I'll let you know what it is used for and everything. And we'll just get rid of this over here. Okay. Now let me create a structure. Okay, I'll use a snippet and I'll call that as stack. And the 2 things that I require in there is one, the stack array, which is the actual array we have, and a top variable. Okay. And also a max size variable associated to that array. Okay. Now this time we are not using this kind of array implementation, but instead we'll be using a pointer. Okay. Because pointers can be used as array equivalents, and we'll do that. We have a stack array over here, and we have a top variable, and we also have a max size variable. Now let us create a constructor to create a structure variable to this structure. Okay. Now if you're from an object-oriented programming background, we also have that constructor and all these associated functions inside that class itself. But since we can't do that, what we'll do is in the constructor function, we'll create a structure variable for this structure. And to all the functions which are listed over here, we'll be passing that same structure variable that we have created as a first argument, similar to the self argument in Python or this variable in Java programming language. We'll create a method called struct constructor. Okay. And it takes in max size input. Okay. Now this is going to return us a new structure variable. And since the structure variable is having a pointer in here, and I want the same structure variable to be passed by reference and not by value, because if you're just passing it by value, we're creating multiple copies of the same thing. So we don't want to do that. What I'll be doing is I'll be returning a struct stack star, because that is the structure variable's pointer variable that we are going to return from this function. Okay. Now I can create a new structure variable for this stack structure, and I'll name it S. And you can see a lot of repetition called struct stack star and struct stack star over here. So what I can do instead is use this typedef. Okay. So I'll just name this struct stack star as small s stack. Okay. So now whenever I'll have to use struct stack star, I'll be using stack. Okay. It's pretty neat. There are people who use just struct stack into stack, and hence they are not involving the pointer in the typedef. They'll have to put that pointer over here, but I just like to involve the pointer too. All right. So I just do that over here. Now what I'll be returning is a stack, which is a structure variable's pointer. And even here, I'm creating a new structure variable's pointer. And since I'm creating a pointer variable, I'll have to use a malloc function. I'm allocating memory dynamically to this. And how do I know what is the amount of memory that will be required for the structure? And I know that because malloc takes in only the size of whatever we're going to create the structure variable to. And the structure variable we're creating is for the structure stack, and the size of that stack can be, and the size of the stack can be retrieved from the size of operator. All right. So struct stack. Cool. So now we're creating dynamically allocating memory for the size of the structure stack, which is 6 over here, I think, because for pointers it is 6 bytes. And for this integer and integer, so it's 4 plus 4, 8. And 8 plus 6 is 14. And I think it should be a multiple of 16, and hence 2 will be padded to it. It's known as structure padding. I think 16 bytes of memory will be allocated for this. I'm not sure, but yeah, that's how it is done. But malloc returns us a void pointer, and here we want a struct stack pointer. And hence we are going to typecast it to the required data type, the required database tag, and we put that over here. All right. Okay. Now, make this clear. We are initializing and allocating memory for the structure variable called struct stack, which is having multiple variables in it, intermediate variables in it, called the stack, which is the array, the top, which is an integer, and the max size, which is an integer. And we can access such by using the arrow operator. if at all this was not a structure variable's pointer variable, we can use that by using a dot operator. But since this is a pointer variable, we'll be using this. Okay. Now, the first things first, we'll have to assign max size to the input max size that we are getting to this constructor function. Okay. This is like a parameterized constructor version of C. Okay. And obviously, the value of top should be -1, because whenever we're creating it, we'll have to initialize the value to -1. Okay. And now the most important thing, we'll also have to allocate memory to this stack over here. And to allocate memory to that stack, we'll again use the malloc function. Okay. And this time, how much memory do you think we'll have to allocate? Because malloc function will have to create space for max size number of integer elements, because we are dealing with integer stack over here. And we get max size by just having max size over here into, since the size of each of those things should be the size of an integer, we use the size of int over there. Okay. So what we are doing over here is, we are not just allocating the stack to one integer, which is size of int, but we are multiplying it with the max size, because if at all we the stack constructor initialized with 5, then 5 into size of int, which is 4 in general. What this will be is 5 into 4, 20 bytes of memory will be allocated for the stack. And this is dynamic, right? Because whatever value we are passing in through this, that is the exact amount that will be allocated to the stack. Unlike having that hard-coded in a macro, and whenever we want to change it, we'll have to update that macro. Because this parameter, we can take that user input and we can pass it as a parameter to the stack constructor. Now, the most important thing, the only reason that we are dealing in pointer variables called struct stack star and not just struct stack is because we want to return that to other functions. And hence, we'll have to return that stack variable back. And we'll just use the same variable that is being initialized to everywhere in all of the functions. Okay. Now, first things first, this, and okay, not that. All these three should be bool. Okay. You get to have this new called bool from the file stdbool.h. That is why we included that. Okay. Because whatever we are returning is of the data type bool. Okay. Now we don't have a top global variable here. So how we do that is, to every function that we have, the first parameter will be stack. Okay. Now that we have the stack we are dealing with, associated top variable of that stack, and we can check for the same thing over here. Okay. Now again, comes over here, stack of s and s of max size and s of top. Okay. Same logic. It's just all these variables are just associated into the same structure, and hence we know that this, it's like, this s over here, what we are using is like a self keyword of this keyword. We just don't have it in C, and hence we are hard coding it ourselves as the first parameter. Okay. And rules first, we'll have to have the stack as the first parameter, because you can have the stack as a second parameter over here too, but I just like to have it consistently. Okay. Now, even to the useful function, now that it takes the stack, we pass in the same s, which is being passed to the push function as a parameter to the useful function. Now, how do you know that this s variable is being passed as a reference and not as a value? Because that is a pointer, and obviously it will be returned, it will be passed as a reference, because stack is of the type stack star, which is a pointer. All right. Now we can return a false over here. Okay. False is just a macro defined for 0, but it looks good and all. Now I'll have to update the stack to top variable if you are pushing it, and if it is not empty. And also, we don't have this stack in the global context. It is associated to that. Even the top is associated to that. And here we are adding that element to that. And we can return it true over here instead of false. Now, same applies to this, because we are returning a Boolean. We'll have the stack S coming to us, and we'll pass the same stack over here. We'll return false if it is empty. And if it is empty, and if it is not empty, we're going to decrement the top variable and we're going to return it true over here. Now, what you can do over here is, if you just want to do that, not only just decrementing them in a stack, but also you can deallocate or reallocate. We have a function like malloc and calloc. We have realloc function too. We can just reallocate that memory in this function, in this pop function, to just 4 variables, the capacity of the current stack. For example, let us assume that pop is called after 3 elements are being pushed. So after the pop is executed, we have 2 elements only. And hence we have to reallocate the memory from 5 to 2. Okay. So this keeps changing for every pop function and every push function. And there are implementations of such too, but I don't think allocating and reallocating the memory so often is a good practice. So I'll just use the waste memory as there. So even now, to be precise, you still have that 1, 5, 2, 4, and 3 over here. And whenever we are decrementing, we are just getting the top value to here, and we are not deallocating this memory. We have that over here. We can do better in the array implementation of the stacks. Okay. And that is how we do it over here. And even for peak, we have stack s, we pass it. And now instead of having this hard-coded minus double line, because at times, even double line can be a value in the peak, which is the topmost element. Or when it comes to contains, it can be the array index of the stack. So what we do is, let us create a macro over here. Oops. And I'll call it stack empty. Always name your macros in capitals. And I have this special variables that we get access to called int max and int min. These come from the limits.h header. Now, this is the maximum value of the integer data type. That the data types in C have maximum and minimum values, and this is the maximum value or the minimum value that the integer data typing can never take. And I don't think we'll be dealing with such big or small numbers while dealing with stacks. So hence, that is the macro that we'll be using. And hence, when we are picking for an element, instead of returning this hard-coded value, we'll just return a stack empty, because stack empty is just int min. Okay, it expands to int min. And since we have the stack, I can just return the topmost element by accessing the stack's top. Even the same applies for fall. We pass in the s. We have the stack empty. And here, we not only send the value of the top, but also decrement it. And since we have to first return and then decrement, we're using the postfix operator over here. And now comes contains. Okay. Contains takes the stack as the first parameter. It takes the int min over here. Okay, not int max, sorry. So stack empty macro. Now let us see this. It traverses from 0 to the s.top, and we have that. Now s.stack, because s is not the stack, s.stack is the actual stack that we're dealing with. That is the array. S is just a structure, which is also having variables called max length and top in it. And we check for that, and we return -1 if it is not containing in that. Okay. And finally, we have the print stack, even for which we'll be passing s. Here we have an s. Here we have s of top coming from there over here. And that's pretty much it. Now, since all these functions now takes 2 parameters, I'll just use multiple cursors, which is, by the way, using control and click. It changes from operating system to system. I'll just do s comma. And where does this s come from? That is what we'll be doing now. We are having a new stack variable called s, and we are going to create that from the stack constructor. And to that stack constructor, we'll have to pass in some variable, and I'll be passing a variable called x over here. And what is that x? It's just some random variable, which I'll be asking the user to enter any number or the maximum value. And I'll just put a scanf over here to take in %d and %x. Oh God, I remember C. Okay. So now we have x. We'll be prompting the user to enter a number, and we'll be storing that in x. And we are passing that over here. And since we are passing x over here, first it goes to stack constructor. It comes over here. It allocates some memory to the stack. It initializes a max size of that stack to 5, because x, for example, let us assume the x value is 5, top to -1. And the allocated memory will be 20 bytes, because 5 into 4 will be 20. And that reference variable or the pointer variable will be returned to us by reference and not by value, because it's whatever we're doing over here is heap-based memory allocation, and heap-based memory allocations will not get drained out of memory while we are out of the execution context of that particular function or that conditional. And hence, they'll be persisted in the memory. And since we are returning it, that same address location of that memory will be stored in the variable called s, which is a local variable to main over here. And that is the same again exact, we'll be passing it to push. And even that will be passing it to useful. And we're creating a reference variable, which is a single reference variable. We are not passing it by value. We are not taking it as a parameter as value. We're just using the same thing the same memory allocation, and we are playing catches with it from one function to function by return statements and parameters. Okay, so yeah, I think this should be over here, and if this takes as this takes an s. Okay, let's check it out. So I'm compiling it and running it. So I'll just click it compile now. It's getting run. Enter any number by pressing 5, and you can see we just first 3 is being printed because obviously the contains function, it takes in the stack and it takes a variable 2, and it comes over here and it checks if the current stack is empty. It is not empty, and it comes to the for loop and it checks if any of that particular structure variable which is being passed, that particular structure variable stack array is having that key or not. And if it is having, it will return the index, and it is having that element which is at the 4th position, which is index 3, and that will be returned to us, and have the print stack function which does exactly the same. All right. So it is the same variable that we're doing. We saved memory over here. Now, there is a lot of improvement from the previous thing. One, we are using booleans over here instead of integers, and where there are no global variables, I can just ignore this stack constructor thing and create a structure variable globally over here, and that we don't need to pass that stack as a parameter to every function that we are creating. That will just be available to every function just like over here. But that's not the point, right? We don't want to use global variables, and hence I've used this thing called constructors and allocating it over here, and dynamic memory allocation and everything. And we are also having some useful macros and a less common number than -9999. And yeah, that's it. So in the next video, this will be the pattern that I'll be following for creating coming up all the data structures. And the next video will be on queues.